Good morning, all. So, as we have already discussed about yesterday, we have discussed about the fluid power. What is the fluid power, and the different types of what we call it as the different ways of getting this fluid power by this hydraulic and pneumatic system, and then we have also okay. What do you mean by a hydraulic system, and what do you mean by a pneumatic system? Okay. Then we have discussed the advantages, the basic components. I just shall quickly recap the different basic components. This was the highlight of the yesterday's presentation. This was a major highlight for the yesterday's presentation. The basic components, that is a tank or a reservoir, or we also call it as a source. Then the filter, motor, pump, pressure regulator, ECV, that is the direction control valve. Then this is the actuator and cylinder. This is the graphical representation of the hydraulic system. Okay. Now components, once again he has given it in the different ways. Now let me talk about the reservoir or the source or the tank. All the three is a different. People use a different notations to describe that. Okay. Now reservoir plays an important role for functioning of system and various components, as well as maintain various working parameters to a reasonable level system. Now, as I have already discussed, the resource reservoir is nothing but a source. Now, before I talk about this, I have already. I just want to give you a small example. Have you seen this? What do you call heat exchanger? Anyway, no, you have seen it. Actually, even in the vehicles, we use it in order to exchange or the reduce or increase the heat. Okay, that is heat exchanger. Different types are there. One type, when it comes to a mixed and the unmixed type, reservoir comes into the category of mixed type of heat exchanger. Okay, so that is the one. Pump and prime mover, just like heart of the human being, create a flow of oil through the system and assist transfer power and motion. Prime mover andre, don't get confused. Prime mover is nothing but in our basic components. Prime mover is nothing but our what is it? Actuator. Actuator. What is the use of an actuator? Actuator is a one device which converts power into mechanical power. That is what we call it as an actuator. So the same work is done by this prime mover also. Prime mover, or you can say it, or you can also say it as an actuator. Based on the area of application, we use the notations. That's it. Okay. Pump is nothing but he says it's a heart of a human being. That means when I say it's a hydraulic system, I want a pressure. I want a higher pressure. Who creates this pressure? Obviously, the pump. So, the pump is called as a heart of a human being, which creates the higher pressure in the hydraulic systems. Then, the next one is a pressure relief valve used in between pressure line and reservoir, used to control or to keep limits. That is what I just told you. Whenever we are designing any pneumatic system or a hydraulic system, we design it for a maximum of working conditions. Say for example, I'm designing one hydraulic system wherein which this hydraulic system can operate up to 10 tons of lifting some weight. So the pressure should be enough and less than the safety level. That means it should not exceed the level of that, and even it should be within that range. Okay, that is what we say. The next one is control valve. As I have already told you, control used to control the energy of the flow expected for controlling the flow, direction of flow, and pressure of flow media and flow quantity. That means the control valve does the four functions over here. It has to control the flow, it has to direct the flow. That means whether it has to go in this line or in this line. That is what we have already discussed here in this. Whether the flow has to go in this line or it has to go in this line. So it will decide the direction of the flow, the pressure of flow, the pressure with which it has to flow in that particular pipeline. As say, for example, we are operating to lift some car or some load over here. It will direct this flow to this bottom portion, and based on the load to be lifted, the pressure will be maintained. That is what the basic idea of this. So the pressure of the flow media will be controlled, and the quantity, what is the amount, what is the quantity of the liquid to be allowed to flow, that will also be controlled by this control valve. So that is what we popularly call it as a directional control valve. Okay, control direction control valve is also nothing but a type of a control valve. We are using here as a directional control valve. Direction control valve is a different type of a one type of a control valve. That's it. The cylinder device that converts the fluid power into linear mechanical force or motion. This is what is shown over here. This is a cylinder with a piston arrangement. So this is the one which takes this fluid power and converts this into linear motion. Need not necessary to be a linear motion, some mechanical power. It can be a rotary motion or it can be some other work also. The only thing is the idea is converting this fluid power into mechanical energy. That is the idea behind of this. Okay, that is a cylinder. Next one is a oil reservoir function. The oil reservoir, what is a reservoir? Is a storage of oil, of oil, expansion of fluid, separation of contaminants, and structural supports easy access. Now, my dear friends, here actually storage of oil, obviously it is a source and a tank. Cooling of oil, that is what I told you, it acts like a small amount of oil which is being moved into this here. Say for example, a small amount of oil a small amount of oil will be flowing over here. When it is being flowing over here, it will be the pressure is increased, the pressure is regulated, and the pressure is decreased, and it will be subjected to when there is a metal to metal contact over here. So, due to the friction, a small amount of friction, I'm not talking about the major frictions, but still, whenever there is a motion, this oil also acts as a lubricant, my dear friends. Though this is also working fluid, it also acts as a lubricant. When I say it is a lubricant, it is will be subjected to the heat absorption, the heat which is being generated over during this all this process will be absorbed by this fluid. When this fluid will be absorbed, when it absorbs the heat, obviously the right temperature will be more. The high temperature or a raised temperature liquid will come back to the oil tank. Obviously, in a large amount of, say for example, you have 10 liters of oil here with 20 degrees centigrade, and 500 ml of oil which is coming at 80 degrees centigrade, then obviously 20 liters, when it compares to the 20 liters of oil, 500 ml is very much less. Then when this mixes with this temperature, obviously the total overall temperature may rise to 20.1 or 20.5 or 30. I'm sorry, 20.5 or 21 degrees centigrade maximum. That's it. So that means we are also reducing the temperature of the oil. Once again, the oil which is going fresh into this filter will have a lower temperature. We are not supposed to send this. And it also does the work. Maybe my dear friends, you might have seen it. In many of our houses, sump is always been made at the front of our main door, correct? Why it has been made? Because above that sump, we go for a parking, we go for keeping some pots, we utilize it for something. So this reservoir or an oil tank also acts as a supporting element or a structural support to host all these pumps and all those things. Okay, so it acts like a platform on the table tara, it acts about which upon which this pump filter everything can be fixed. Okay, then it also acts as an expansion of fluid, obviously, separation of contaminants. When it is going all through this, there may be some possibility of contaminants. The contaminants may be different types. One may be a dust particles because of the leakage. Second one may be the metal, minute metal particles which may come across during this friction. So all these things, and even in most of the things, what happens if you keep using the oil, even whether it is a two-wheeler or a four-wheeler, engine oil, after few kilometers, the color and the thickness of the oil does changes. Why it does changes? Because it will be subjected to continuous heating and cooling process. So the viscosity and as well as the thickness, viscosity and even the color does changes. So all this is because of the contaminants. So this also reduces separation of the contaminants. Okay, then the structural support, that is what I said, and easy access. These are all the different types of different functions of a reservoir. Then fluids I have already discussed. Liquids plus gases, we call it as a fluid. Fluid refers to both gases and liquids. Fluids, liquid is a fluid that for a given mass it will take the shape of its container, liquid or incompressible. Obviously, the only assumption what we make it is the only incompressible liquid or a fluid which is available is water and air. That is what we say. Air is the only common used gas in fluid system because of its inexpensive and readily available. It's compressible. Okay. Now hydraulic fluid or a transmission, my dear friend. Now this gives a clear picture for you people wherein you can take let F be the force. Okay, P be the pressure in Newton per meter square and area is nothing but meter square. Now here, can you able to see this? Now this is diameter, this area is less, whereas this area is more. This area is more, whereas this area is less. That means this area I can take it as an A1 and this area I can take it as A2. Okay, now this is the force which I am applying it on this plunger. You can say it as a plunger or you can also say it as a piston. Doesn't matters a lot. Only thing is it is a mechanical element which we are keeping here to force because liquid, how much ever you cannot compress the liquid keeping in your hands, right, my dear friends? So what we do it is we will keep it in a container. Make sure that container will be completely covered with a piston or a plunger with the sealing arrangement. If you don't have a sealing, obviously what happens whenever you compress, it just comes out. So this I call it as a plunger or I call it as a piston, doesn't mind. So this is an area one, and here we have a car now which has been placed on the a plunger or a lift where it has an area of A2. Where by observation itself you can make it out whether this area one is greater or A2 is greater. Obviously A2 is greater. Then force required, force required to lift this car is more. So what we'll do it is whatever the force F1, the newtons of force you are applying it here on the plunger, that will be transmitted to the fluid. That means a mechanical power is being converted into a fluid power, and this pressure will be completely takes place and undiminishes. My dear friends, take for example, if you are applying at this point or at this point or at this point, anywhere, the force, if you are applying 10 newtons, the same 10 newtons of force completely, that is what I said, undiminished. Undiminished means whatever the amount of force you are applying, the same amount of power will be transmitted. If you apply 10 newtons, it doesn't mean that it will go on the apply around 9.5 newtons. No, whatever the force you are applying it, the same amount of power will be transmitted over here with undiminished. That is equally 10 newtons will be carry on. Now the same thing will be transmitted over here and it just lifts. So I will explain this. I will come back to this once again and I will let you know. The same thing. The second position. This A to B, whatever it is called, it is a displacement. Now, now you can see it here. I have moved more to lift so much. Can you please tell me whether this S1 displacement is more or S2 displacement is more? Obviously, S1 displacement is more. S1 displacement is more compared to the S2 displacement. That means since the area is less, since the area is less, I am displacing it more. Since the area and force required to lift this is more, what I will do is only this much. Is it clear? This is how it will be compensated. And all this is now this is nothing but a hydraulic lift ಅಂತ ಕರಿತೀವಿ ನಾವು. We call it as a hydraulic lift. Okay. Now this basically works on the principle of Pascal's law. Okay. Now I will define the Pascal's law. Energy in a hydraulic systems. Energy in a hydraulic system. It's the ability to perform work. That is okay. But it's a limit. Now, pressure applied to a confined fluid is transmitted equally in all directions throughout the fluid and acts perpendicular to the surfaces in contact with the fluid. Equally, you can say it, or undiminished also you can say it. Now, my dear friends, 1 second. You're able to see it here. Say, for example, if you take a water bottle, if you take a water bottle over here, if you take a half liter of water bottle, in the half liter of a water bottle, you will have a lot of granular over there. That means up and down, irrespective, different shapes will be there. You take half of the water in that water bottle and you just compress it, and it will be squeezes. If you want to regain the shape back, it is not possible to regain it. I'll give you one idea. Fill it completely. Fill it completely, close it and apply the pressure from the top to bottom. Then obviously the whatever the displacement, whatever the inner ಒಳಗಡೆ ಎಲ್ಲ ಏನು squeeze ಆಗಿರುತ್ತಲ್ಲ, obviously it regains its places. It regains its shape. How it does happens? That means irrespective of the shape of your bottle, irrespective of the shape of your bottle, the force which you are applying at the top of the bottle will be carried or it will be transmitted. That is what the water which is there in the bottle is, which we call it as a confined fluid. The pressure applied onto a confined fluid is transmitted. Whatever the load you are applying, maybe 2 newtons or 1 newton you are applying it, is that force is transmitted undiminished. Actually, I'm so sorry. Actually, I should have given one more word. Undiminished. Undiminished means the same amount of, if you're applying 2 newtons of the load will be transmitted undiminished. That means the same 2 newtons will be applied at bottle equally. That means whether the bottle, say for example, water is up to here, at this point, at this point, at this point, every corner of inside of the bottle, it applies the same. If it is applying, if you have applied 2 newtons, the 2 newtons of the force will be applied at the bottom of the bottle, at the side wall of the bottle, on the top of the bottle, or the corner of the bottle, irrespective of the shape and the size of your bottle, it will be equally applied in all the directions. In all the directions, like our sun rays will be displaced in all the directions. In all the directions, it will be equally applied throughout the fluid. Throughout the fluid. That is what he says. And it acts perpendicularly. And it acts perpendicularly. That means if this is a water level, so it will be acting perpendicular to this. If this is the side of your bottle, it will be acting perpendicularly. Now, bottle will be of a curvature. Now it will be acting perpendicular to like this. So every corner, it will be acting perpendicular to the surfaces in contact with the fluid. That is what he says. X, Y and Z. X, Y and Z in all the 3 directions. The force will be, the pressure will be applied equally in all the directions. That is the beauty of this Pascal's law. That is the beauty of this Pascal's law. Is it clear? Now, even you can experiment it. You take any mineral water bottle, you take half of the water bottle, okay, half filled, and squeeze it, and then you try to regain the shape back. It is not possible. Then you fill it completely, fill the water bottle completely, and apply the force from the top. make sure that you apply it in such a way that there should not be any air gap. When you apply it completely, irrespective of the directions, it will regain its shape. That is the one you can experiment it to study to understand the Pascal's law. Now this completely pneumatic and hydraulic system does works on the basic principle of this Pascal's law. Okay, now he has given examples: hydraulic jack, hydraulic press. Hydraulic jack, you must be knowing it. Okay, hydraulic press is nothing but the emblems ಗೆಲ್ಲ ಮಾಡಕ್ಕೆ ನೋಡ್ತಾ ಇರ್ತಾರೆ ನೋಡಿದ್ರ emblems. That is nothing but a hydraulic jack, hydraulic press. Is that clear? Pascal's law has got a wonderful application. There are two more theories which are related to this Pascal's law in order to study this hydraulic. No, basically, don't get confused. Hydraulic systems and the pneumatic systems completely works on the basic principle of Pascal's law. Is that clear? Since this hydraulic and pneumatic system that works also on the fluid, I will also be going to discuss two more theories, that is the continuity equation and the Bernoulli's equation. Okay, that you must be knowing, you have already studied in fluid mechanics, but still I'll go through this quickly. Before I go through this, the other two basic laws, I just want to tell you once again the Pascal's law. I will make it very clear because the complete theory or subject does depends upon this Pascal's law. Pascal's law states that, my dear friends, whatever the statement I have given in the slide, I'm just changing it with one or two words. Pascal's law states that the pressure applied onto a confined fluid is transmitted undiminished, equally in all the directions throughout the fluid, and acts perpendicular to the surfaces in contact with the fluid. Point to be noted, it acts perpendicular to the surfaces. Yeah, surfaces they the surface which is in contact with the fluid. If the surface is not in contact with the fluid, it doesn't apply. Now, clearly mention it. Then you take a half liter of water bottle and then you apply it, and then you squeeze it, it doesn't come back because when you take half liter, half of the water bottle, the empty air gap doesn't will be in touch with the liquid or fluid completely. So there will be an immiscible. I'm so sorry. There are two fluids are there. You completely fill it, then it does happens. You can argue me, sir. Even the air is also a fluid, wherein which pneumatic systems are. No, my dear friends, please be careful here. When you take a 1 liter of water bottle, half of the water bottle is filled with water, and the half of the bottle is with the air. Both are fluids only, I agree. When you apply the load, now my dear friends, the density of water is 1000, whereas the density of the air is 1.12 kg per meter cube. Correct? So when there is a density difference, whatever the load that you are applying may not be same for the air as well as the water. That is the reason it is not doing that. Is that clear? Now, even if you want it, empty the bottle, squeeze it, empty, make a 1 liter, take a 1 liter bottle, squeeze it, it is filled with air, but that air doesn't have a pressure. If you can fill the air with a higher pressure, obviously it regains its shape. Finished. You can try it also. You take that 1 liter mineral water bottle empty, squeeze it, and take that compressor. If you go to any inflating workshops and all those things, there will be compressor. Take this, inflate it with that, and you will get, and you will get the regain of this shape. That is what. Okay. Now he says the pressure applied at x in the x direction is equal to the pressure applied in the y direction and the pressure applied in the z direction. That means in all the three directions, the pressure applied, the unit pressure applied will be the same. Is that clear? One second.
Sir, voice break ಆಗ್ತಿದೆ sir.
Your voice is not audible, sir.
Is it not
Break
there?
ಆಗುತ್ತೆ.
Now is it okay? Now is that okay? Can you hear me?
Somewhat. Yes, sir. Yes, sir.
Now is it okay? Clear? Is it okay?
Yes, sir. Okay.
Okay, okay,
Okay,
perfect.
sir.
From tomorrow, I'll try to use some earphones. Appa. Okay, okay. I was just talking about continuity equation. My dear friends, I guess you are already familiar with the continuity equation and Bernoulli's equation. Once again, as a formality, as a customary, I will explain you. A continuity equation states that in a steady flow, in a steady flow, the pipeline, the fluid flow rate is same in all the locations of the pipe. That means Q1 is equal to Q2 is equal to Q. That means A1 V1 is equal to A2 V2. Okay, and Bernoulli's equation, by the conservation of energy, the total energy possessed by the fluid at point 1 is equal to the energy possessed by the fluid at point 2. That is, Z1 is represents, what is this Z1 represents? Z1 represents the potential energy, P1 represents the pressure energy, and V2 represents the kinetic energy. Will be constant in each point. That means in a steady flow means, what do you mean by steady flow? Rate of change of velocity with respect to the time is constant. In a steady flow, what happens? The discharge at one point is equal to discharge at point two. That is what continuity equation says. The conservation of energy, what does it says? Energy possessed at the point 1 is equal to energy possessed at the point 2. That means, say for example, at the point 1 you have some potential energy, pressure energy, and kinetic energy. The sum of this is equal to the sum of the energy possessed at the point 2. Is that clear? Next one is energy in hydraulic systems. Energy in hydraulic systems, it's the okay, frictional losses in the pipeline. Obviously, the frictional losses you have already studied, the losses in pipes, valves, and the fittings. Obviously, whenever you have a valve in a straight pipe without any connection, doesn't fetch to any frictional losses. That will be a minor losses. Frictional losses are the major losses, and the minor losses are nothing but the bend, walls, and all those fittings will leads to that. Okay, now the laminar and turbulent flow. Fluid flowing in smooth layers or laminae is laminar flow, and fluid flowing in a random or fluctuated is known as turbulent flow. Reynolds number, if it is less than 2000, people say it is 1500, and few people say it is 3000. When it comes to the hydraulic systems, you can say it is a 2000 if the Reynolds number is less than 2000, we call it as a laminar. If it is a greater than 2000, we call it as a turbulent. Actually, in between this laminar and turbulent, there should be some transient level also, which we are not concentrating more on that. Okay. The structure of hydrostatic drive. Aggregate, this is a one sketch, is a normal flow diagram that they have given it. Aggregate, control elements, and actuator. Aggregate is something which we are creating the pressure. It includes the reservoir, a filter, all those things, pump, motors, fluid reservoir. This aggregate. Now, my dear friends, this is the, who is this Manjappa? Now, this aggregate uh, means ಏನು ಮಾಡಿಟ್ರಪ್ಪ ನಮಗಿದು. Okay. Now this the since it is a theoretical subject, it is always advised to represent present the answers in some picture wise or in a flow diagram wise. Now here, and I have tried to put this in a flow diagram. This aggregate includes pump, motors, fluid reservoir, filters, piping, and pressure relief valve. Up to this, we call it as an aggregate. Control valves are like directional control valves, determining the path, pressure, flow rate of the working fluid. All these things comes under the category of control elements. Then the actuator. Actuator means elements doing the work, maybe a linear flow, linear motions, rotational or swinging. I just told you. Mechanical power or mechanical energy need not necessarily to be a linear motion only. It can be of any type of mechanical energy. It can be linear or rotation or swinging. These components and their interactions is the subject of this semester. Okay, this is the one way. Fluid power and its scope. Fluid power is a technology that deals with the generation, control and transmission of forces and movements of mechanical element or system with the use of pressurized fluids in a confined system. This is a point to be noted. Every time we always say what is a confined system. Now, what do you mean by this confined system? What do you mean by this confined system? Confined means the area which is under concentration. When I'm talking about 1 liter water bottle, for me the world is only water bottle. I'm not bothered what is around of it. So that is what we call it as confined, which is under observation or which is under attention, which we call it as confined system. Is it clear? Both liquids and gases are considered as a fluids. Fluid power systems includes a hydraulic system. Hydra means water. That is what in the Greek, and pneuma means air in Greek. Actually, Greek people are the one who started this fluid power or hydraulic systems and pneumatic systems. So obviously they have called it as hydraulic and pneumatic system. Okay, oil hydraulic employs pressurized liquid petroleum oils, synthetic oils, and pneumatic employs compressed air that is released to the atmosphere after performing the air. Now, my dear friends, here sharply I have also mentioned what are the different types of oils that are being used in the hydraulic systems. One is the synthetic oils, the second one is the petroleum oils. Okay, I just tell you synthetic oils and petroleum oils. What is the difference? I talked about that in later stages. And in some cases, water is also used in only in a few cases. Because as I've already told you, water tends to rusting of the equipment. Okay, that is why. The term fluid we refer to the air or oil, but it has been shown that the water has certain drawbacks in the transmission of hydraulic power in machine operation and control. The application of fluid power is limited only by the ingenuity of the designer, production engineer, or plant engineer. That means application of this fluid power is limited only based on the requirement. Whatever we design it, based on that it will be utilized. Then, if the application pertains to lifting, pushing, pulling, clamping, tilting, forcing, pressing or any other straight line and any rotatory, it can be motion, it is possible that fluid power will meet the requirements. Okay. Hydraulic fluids and task. Primary task is power transmission, pressure and okay. The next one is signal transmission for control. Secondary tasks. The major aim of the hydraulic fluids is to power transmit and then signal transmission. Okay, next one is secondary tasks: lubrication of rotating and translating components to avoid friction and wear. My dear friends, please be careful here. This lubrication of rotating or translating components, that means whatever we are moving over here, everywhere, everywhere, this motion is being controlled by whenever there is a mechanical linear motion, it has to be lubricated. And this lubrication will be done by this fluid. If you use a water, can it do this lubrication? It is not possible. That is a major one. Okay, now let me come back. Secondary task of this hydraulic fluid is to, I'm talking about only the fluid, my dear friends, is to lubricate the rotating or translating components to avoid friction and wear. Next one is heat transport and take away from the location of heat generation, usually into the reservoir. That is what the second. Transport of particles to the filter, protection of surfaces from the chemical attack, especially corrosion. Now, all these four tasks cannot be accomplished by the water if you use the water as a working fluid. Is that clear? Okay. Physical properties of a fluid which are required. The physical properties which are required for this is Good lubricity, it should be a good lubricant, it should have an ideal viscosity, it should be chemically stable. Stable means it should not react with the metal surfaces of medium. That is what we call it as a chemical stability. Okay, high degree of incompressibility. It should be mostly incompressible. If it is compressible, obviously it cannot uh, carry over the pressure that has been applied at the one end. It should be fire resistance. This is a point to be noted. It should be fire resistance. If it is not fire resistance, what happens? Because of this high friction or a high temperature, it may catch fire. So it should be, in this regard, we also concentrate on fire and flash point. Fire and flash point, we will be concentrating it. Okay. Good heat transfer capability, low density, foam resistance, and non-toxicity. Toxic. It should not be a toxic one. That is what they say. Okay. Then hydraulic fluids requirements. What are the requirements of a hydraulic fluid? High flash point, or in certain cases not inflammable at all. It should not be inflammable. That is what we say. The one which we are using it should have a high flash point, or in certain cases not inflammable at all. Andre, it should not catch fire at all. That is what he says. Okay. Next one is chemically neutral, not aggressive at all against all materials in touches. Say for example, there are chemically active liquids where if you touch them, it will react. There are many, you might have come across with many occasions. It should be chemically neutral. Low air dissolving capability. Low air dissolving capability, not inclined to foam formation. Foam formation ಆಗಬಾರ್ದು. That is what foam formation. Foam ಅಂದ್ರೆ soap ಹಚ್ಕೊಂಡು ಕೈಯಲ್ಲಿ ಉಜ್ಜಿದಾಗ ಏನಾಗುತ್ತೆ, foam ಬರುತ್ತಲ್ಲ, that should not be the case. That is what he says. Next one is environmental friendliness. No environmental harm. It should not be environmentally harmful, and there should not be toxic effect. Okay, these are all the requirement of hydraulic fluid. Hydraulic fluid types. Water is used. About only 3% of applications, in hydraulic applications, water is used. Mineral oils, it is used maximum. Mineral oils mineral oils, petroleum oils comes under the category of mineral oils. So 75% of the applications are based on this mineral oils. Not inflammable fluids, only 9%. Biologically degradable fluids. Biologically degradable fluids like our daily using the vegetable oils, something like that. Biologically degradable they are all. So 13% they are using it. And electro-rheological fluids. This is still under development, still they have not been achieved. This is what. Okay. Now it is already it's getting time up. So